Hello, students. Okay, we are talking about acids, bases, pH, pOH, Kw, and a few other things. Let's take a look. You all know what the pH scale looks like. pH goes from 0 to 14. Below 7, you're an acid. Above 7, you're a base. If you're right in the middle, you're neutral. But we're going to talk about this thing called the Kw constant, or the dissociation constant for water. So water molecules crash together, and every once in a while a couple of them break. Usually they just rebound off each other and they just remain as H2O, but every once in a while a couple of them actually dissociate into the ions H positive and OH negative, like that. And so in a beaker of water you would have like mostly just a bunch of waters. But there are these small concentrations of H positive and OH negative. The concentration of water is massive. It's so huge. It's 55.5 moles per liter. It's basically a constant. The concentration of H positive and OH negative is super small, 0.00000001 moles per liter for each ion. So very small. So if I was to do this, if I was to go Kc equals products over reactants, and I was to plug in numbers, I'd have 1.0 times 10 to the negative 7 times by the same number again, divided by 55.5. Now the 55 is so huge, we just say, you know what, that's a constant. The other numbers are so small compared to that massive number. We're going to just multiply that in and call this Kw. And Kw is the dissociation constant for water, which always equals 1.0 times 10 to the negative 14 moles per liter squared. Okay, we'll see that number again a little later. You just need to know where that, what that number is and that it's a constant. Okay, now let's go look at these acids again. So when I'm talking about acids, they have concentrations. So 10 to the 0 is actually 1 mole per liter. 10 to the negative 7 is super small, 6 zeros and a 1. So decimal 0.000001, and then even smaller, right? So that's 1 mole per liter. So these get very, very tiny numbers as you move up the scale. So that shows me that the concentration of H positive is going down as I go along that scale. If I take the power of hydrogen and make it positive, take negative 7, just call it 7, that's actually how we get the pH scale. It's the power of hydrogen scale. So what do you need to know? Well, you need to know when you're up at on the left side of that scale, you have small numbers like pH of 0, pH of 1, but they represent great concentrations, like a large concentration of H positives. So the diagram at the bottom shows kind of visually that your highest concentration of H positive is over on the red side, the left side. Okay, same thing with the bases. I just take the exponents and make them positive, but it's going the other way. The OH negative is high on the right side of the scale. That's where my great concentration is. Okay, and so I still know that these are acids over here, these are bases. Okay, each jump on the scale is a jump in 10 times the concentration, weaker or smaller, depending on which way you're going and on what end of the scale you're on. Are you on the pH side or the pOH side? But each increment is 10 times. So that's not, if I go from a pH of 2 to a pH of 5, that's not 10 times 3, that's 10 times 10 times 10. That's 1,000 times weaker or stronger if you're going the other way. So if you go from a 2 to a 5, you're getting 1,000 times weaker in terms of the H positive concentration. Okay, now let's look at some formulas. So in this course, pH, well, always, pH plus pOH equals 14 every single time. 11 and 3, 14. 10 and 4, 14. pH plus pOH always equals 14. That's our first formula. We can be we can be given the concentration of acid, and we can find the pH from it. Or we can go the other way too. So here's an example. If they gave me 10 to the negative 11 and they said, what's the pH? Well, that's easy. It's 11. I just take the exponent, make it positive. But what if I'm not on one of those exact hash marks? What if I've been given the concentration of 2.7 times 10 to the negative 10? Well, what would be the pH? Well, it's an easy formula. It's negative log the concentration of H positive. So on my calculator, I push in negative log and then 2.7, and I use second EE and then put in negative 10. And then I get pH equals 9.57. Okay, so that's that formula. Same formula on the other side of the scale for pOHs is negative log concentration of hydroxide. Okay, if I was given 9.57 and said, what's the H positive concentration? Well, H positive equals 10 to the negative pH, to the power of negative pH. Okay, so if I go 10 to the negative 9.57, I will get my 2.7 times 10 to the negative 10. Okay, and same on the OH side of the scale. And then I can also have this formula, and here's our kW constant again. H positive times OH negative always equals 1.0 times 10 to the negative 14 moles per liter squared. Okay, so there are our formulas. You might need to know this one from last year. Moles divided by volume gives you concentration. There's the dilution formula. But now when you do a calculation or you're given a problem, they could give you pH and say find the pOH, the H positive, and the OH negative. And the math is simple enough. You should be able to go all the way around and find all of those numbers for any beaker that has water in it. Okay? All right, that's quick, and that's how we do that, and then there's some work to do in your assignment. Okay, thank you.